Hi everyone, my name is 𝗏𝗏𝗃𝗀𝗃. I'm a developer advocate here at Timescale. And for Timescale Tuesday this week, we're going to finish our mini-series about the function in Postgres called 𝗥𝗏𝗃. And I've titled this one Making It Real with 𝗥𝗏𝗃, really as kind of the final follow-up to try and give you some tools for your tool belt when you are looking at an application, at a tool set like Timescale and a database like Postgres, ways that you can generate data to help you understand what you're working with. So the first video in this little mini series about 𝗥𝗏𝗃 was really just an intro. What is 𝗥𝗏𝗃? How do you use it? And when you see it used in examples in our documentation and in other places, how is it that we're coming up with tens of millions of rows of random data to demonstrate some of these time series functions? What does that really look like? How is that working when you see those examples? So that's what this first video is about. I'll link to it below in the description. The second video, which I did a week or two ago, was really about creating more realistic data. One of the problems with some of the things that we provide, and a lot of people, is that 𝗥𝗏𝗃 is often used with the random function. So a way to produce just random data so you get lots of it really quickly. But it doesn't mean it's very realistic. And even if you use random, there are ways to produce ranges of values. I showed you a couple functions to produce random text, for instance, so that you can at least produce some data that's a little bit more realistic to your use case, and then you can scale it based on using multiple sets from 𝗥𝗏𝗃 to get millions of rows very quickly that you could then insert into a hypertable and begin to manipulate and test functions and so forth. So for this last video about 𝗥𝗏𝗃, what I'd like to talk about with you is how to actually create more realistic looking data, not just physical numbers, but maybe start to give shape to your data. Just one more tool in your tool belt when it comes to quickly generating some data to play with. And so let's go ahead and get right to it. Now, in weeks past, I've mostly been using this tool called 𝗔𝗵𝗽. So you'll often see us either use a terminal with pSQL or a tool like this that allows me to show you the SQL above. And then if I run that SQL, I get a value down below and you get to see the results here once it connects and we get going again. And so this is really useful, but it is not as easy to graph data. So I want to talk about shaping data and why you might want to do that based on some new functions that we're providing to you in our analytics tools. So this is a great way to show you how to create more realistic random data, but at least was within a range of something you might want to show if this was showing truck data, maybe in a fleet as they travel around the state. And so for this example, I want to graph some stuff. And what I'm going to use is actually a tool called Azure Data Studio. It's provided by Microsoft, and it's kind of the Visual Studio Code for Microsoft SQL Server, but they also support Postgres. And then built into Azure Data Studio, much like Visual Studio Code, they actually support Python notebooks and other kinds of notebooks. They actually support a SQL notebook. So you can actually do blocks of SQL and then see the output. For this, I wanted to graph it. And so I just am creating a Python Jupyter notebook is what this is. Now, this video is not about creating a Jupyter notebook. So I'm going to skim over that pretty quickly. I mostly want to talk about how you can now use 𝗥𝗏𝗃 to shape data to create some things that might be more realistic for the samples you're providing. So here's how this works. This first section honestly just sets up this notebook so that I can connect to my local database. Now, again, we've said time and again, when it comes to 𝗥𝗏𝗃, you're not actually retrieving data from the database. You can join to that, and we're going to show that in just a minute, but you still need Postgres, the database, available to you. So it is a function inside the database. It's just producing the data and returning it to you. It doesn't actually exist in a table. And so in this case, I'm just running a select statement that says generate series 1 to 4, and I get the result 1 to 4. All right, so I know I'm connected. I know things are working. So one of the first things I wanted to show as an example is how you could use something like 𝗥𝗏𝗃 in two different ways to create something that looks like a sine wave. Now, I'm going to show you why you might want to do that in just a minute. But let's look at the first example. This is actually something we show in the documentation for our new timescale analytics functions, which we're going to be making available. They're actually available in beta right now. In the next few weeks, you should hear hopefully some announcements on our 1.0 release. But we give this as an example, and it's a really interesting case here. There are two ways to do this. The first is, you'll notice here that in this example, we generate series from 1 to 20 in steps of 0.1. So we'll end up in this case with about 200 points. We take that value, represented as TS, all right, we pass that into a little date math. We say, hey, start at 2020-01, so January 1st of 2020, and add the value for every row, add the value of what's returned from generate series to, we multiply it by 10, and so we essentially get, we start 10 days ahead, because the first value is going to be 1. So 1 times 10 is 10. We add 10 to January 1st, we get January 11th. And then for every row after that, we're incrementing by 0.1, which ends up being 1 more day. So we're just doing simple date math in Postgres. And that gets us our time on that axis. And then we're doing a little cosine math. So we're simply taking the value of the output from generate series on every row, and we're feeding it into the cosine function with a couple other little addition and multiplication to get points of data. So what that looks like in reality, now again, this is just Python that's simply connecting to the database, running this SQL statement and giving me the output. So in this case, you'll see that I get not quite 200 rows, and it starts for me in this case on January 11th. That's just because of how it was done for this sample. And we do a little cosine as we go, and we get some values that start high and eventually come low based on the radians and so forth, doing the cosine, and then it comes back up. And we end up with a sine wave, which is hard to see until you actually plot it. So that's what we're going to do here. Oops, wrong. Uncomment that. Sorry about that. So we can plot this, and we end up with a sine wave. So I'm going to show you in a minute why this might be useful to you. You'll notice that we did this in a specific way. We first generated just numerical values and did date math. In the other examples we showed previously in some of the other videos, we actually generated the dates and then wanted to do something with that. And so I actually showed, I believe, this trick in the previous video. There is a window function called row over. And what that does is it will produce a column or a value based on the row of the output. So if you have 100 rows and you do row number over the rows, you end up with a number 1, 2, 3, 4, 5, all the way to 100. I can use that as a value to feed in other parts of the SQL. So in this case, we're doing the exact same thing, but we're generating the dates instead. And then instead of doing using the value from generate series, we're saying, hey, we're going to get a bunch of rows with a value, a date, add the row number to it, and feed that into the cosine function. And I essentially multiply it by 0.1 to get the same small increments over time. And if I do that exact same thing, you'll see that the data frame looks very similar. So this is the output from that function. Now I'm off by a day just because of how I did the math. It was my fault. But graph-wise, we'll see that this ends up with the exact same graph output. So you start to see that if I were to feed this into, and there we go, we have our same graph. If I were to actually take this value, insert it into an actual hypertable, and then graph this through another application, I would have, a form of data that I knew what to expect. I knew how long the data took. I knew the basic range of the data, and I knew that it was a sine wave that, had an amplitude about every 2 to 3 months. All right, so I could figure that out. Now, why is that important? Well, I'll show you for some of our functions in our new analytics. One specifically, and I'm just going to bring this over here, is something we call last triangle, not we call, it's a way of graphing and downsampling data, largest triangle, 3 buckets. And so we actually use this example right here to generate series so that you could run this yourself and see how downsampling the data further starts to make this look a little bit less precise, and that even further, it gets a little bit more straight lined. all the way down to a very, very downsampled data, maybe 1 or 2 points per day. And so it's just another great use case for something like generate series when you need to test functions like this. Now, the other thing that I wanted to, this got me thinking, honestly. I was like, that's kind of cool. I can create sine waves, but, for me, it really becomes, how do I generate data that maybe is more realistic to what I want to show? So a lot of people use Timescale for things like monitoring, maybe for, IoT data. Maybe it's monitoring your website traffic. And so, I can create some sample data. This is very similar to what we've seen before. I generate a date range. This is 1 year of data, one interval, one point per day. 1 date per day. And then I'm just generating random values, multiplying it by the row. Now, what's that going to do? That's going to give me a simple kind of, linear plot. It's going up over time because I'm multiplying it by the row number, which is increasing. And I'm getting random data that's bouncing back and forth because I'm multiplying some kind of small number by a number that's increasing over time. So I get a lot of difference in the amplitude, but it still is going up. Now, that might be what I hope for my website. I want traffic to go up over time, but I don't want it to be so random that it doesn't look realistic. So I got thinking a little bit more. Well, could I do more with this? And I started to think about what I just showed you above, taking something like that sine wave. And I thought, maybe I could use that sine wave to add seasonality to generate series. And so this example, and I will make this available. We're actually working to get a repository for all these videos and the SQL we come up with. But if I could take that SQL and I could generate a cosine function, but a sine wave of some length, so I knew that it peaked maybe 2 or 3 times a year to simulate sales. Maybe my sales are higher in July and December because it's seasonal in some way. So I wanted to have the data increase over time, but have some peaks during a couple of those periods. I thought that'd be pretty cool if I could get the same effect. So essentially, I'm doing, I had to play around with this. You would have to decide what your specific mathematical function here would be. For me, this essentially said, hey, generate 2 different series of data. One is going to be a sine wave, and one is going to be just a set of dates. And where they join up, give me the row number, give me the value from the sine wave so I can use that to kind of, influence the curve of my data, and then spit some output to me. So I get a day and eventually a value that is influenced in some way by the sine wave that I'm generating it to. So what does that look like when you generate it? Hopefully you think this is kind of cool. You'll see that instead of that very straight line random graph above, I now have a data that increases over time. This is 2 years worth of data. It peaks at certain periods of time. So in the summer and near the end of the year, and then it goes down again, kind of in April, comes back up again in July, and back up again at the end of the year. And so I did that by combining 2 generate series, both with some mathematical functions in them. One was a sine wave, and one was honestly just random data that I'm influencing based on the row number and this sine wave to get something that's, a little bit more realistic. I just thought that was kind of fun and maybe gives you some ideas. And so the last thing I wanted to show you is maybe you don't want to be that fancy. Maybe, you want to give an example of something you're doing and similar to this. So one other way you could do this is instead of something a little bit more random like that sine wave, the upper and lower bounds, but you don't have precise control over each month and maybe the kind of influence you want the data to have in any given month. Maybe you know that the month of May is always a really slow month and the month of July is a really, really busy month. Things really, you have a lot higher traffic, a lot more sales during those months. You could, instead of joining your generate series to a sine wave, another set of generated data, you could connect it, you could join it to a real table. And so that's actually what I did. I generated just a very simple table. I called it overrides. It has 2 values, what I call mval, which is the month. I don't know why I called it that, and a p increase value, so percentage increase. And I just made these numbers up. For 12 months of the year, in any given month, how much above or below what the number would be do you want me to push the values? So as time goes on, in a given month, like, so in this case, you can see that in June and July, I really made those numbers bigger, 25% increase, 28% increase. I expect those months to be higher, but some months, like what is this, March, I really don't want the numbers to change all that much. And so I should at least see some shape in my data. So let's go back and see what happens. So again, I have a month and a percentage. And when I go back to this example, you'll see that I join to the overrides table. I say, hey, for the generated series, pull out the month and join to that table, and then grab that percent increase value. And so for every day that you provide, I'm going to get a month increase to bump this by. And I take that percent increase and I just add it to my multiplication. It becomes my influencing number. And so that's all that's happening down here. And you'll see this is going to look different from that sine wave, but similarly, it trends up over time. I get some peaks in a couple of months as I wanted it to happen. So in the middle, in the June, July, and again at the end of the year. So this gives me a little bit more influence. And there's lots of things you could do here. You can keep playing with this. This formula is what's going to determine what value spits out in your graph. So I could do things like, I could, this is going to get a little bit crazy here, but I could instead say, hey, go ahead and, make this exponential. And so if I do something like that, I get a really crazy graph over time. I'd have to play with these numbers then to say, well, that's not quite what I want. There's lots of ways you could influence the time. You could, divide by a larger number or a smaller number to really start to hone in on what you want and get the upper and lower bounds of the values that you need. So yeah, this is kind of the end of this section. I was having fun. I was helping our team doing the analytics, seeing the sine wave, preparing these videos, and saying, man, how can I bring some of this together to help users better understand the tool, quite honestly, but produce data that might really help demonstrate what you need to do and how Timescale could work in some of those instances for you. So that's the end of the series for now. I'm sure there's more we could do with it. And if you have ideas or questions, let me know in the comments. Come find us at slack.timescale.com. I'm in there as often as I can be, hopefully a couple times a week at least. Subscribe to this channel. I've been saying this week after week, we're trying to do more with this. We're in the midst of releasing a lot of new features, bringing new staff aboard to help us, new developer advocates to help make more of this content. And we just really want to help you both be a better user, a successful user of Timescale and with Postgres in general. So please subscribe. Look at the links below for the previous videos. I'll link to the last one here to my left, your left, I guess, my right. And hopefully we'll see you back here next time. Thanks so much for watching. Have a great day. Take care.